All right, 14, a 32-foot extension ladder is leaning against a building. The ladder touches the building at a point 27 feet off the ground. What is the angle formed between the ladder and the building? All right, so again, we're going to start with a picture. Now, when we are reading through this, when it says the ladder touches the building at a point 27 feet off the ground, that does not mean it is touching the top of the building. So we actually have no idea how high our building is. So when I draw my picture, I'm going to illustrate that. All right, so this is my building, and here's the ground. I'm just going to make my ladder here. Okay, so this part right here, that is so from here to the ground, this is 27 feet. And then the ladder is 32 feet. So this was my ladder, so this is going to be 32. And I should be labeling these to make sure I remember what it is. And it says the ladder touches the building. Okay, what is the angle formed between the ladder and the building? So if this is my building and this is my ladder, it is asking for this angle up here. And we're, again, making an assumption the building is making a right angle with the ground. Okay. Now this time we're finding an angle, so that means that we need to use our inverse trig functions. Now we're still using SOHCAHTOA to help us. So if this is my angle, I have the hypotenuse and I have the adjacent side. So that means that we're going to be using cosine. Okay. And because, again, we're finding an angle, it's the inverse. So I'm going to have inverse cosine. And then the adjacent is 27 over the hypotenuse, which is 32. Okay. And that is going to be equal to my angle of x. Okay. So at this point, I'm just typing this into the calculator. And again, it doesn't tell us where to round, so we are going to be rounding to the nearest tenth. So x is going to be approximately something. So again, on my calculator, okay, again, make sure in your mode button that you're checking that it's in degree. Okay, so mine still is. And then to get to the inverse, so here's cosine. I need the inverse though, so since it's above, I have to press the second key and then cosine to get the inverse. And then 27 divided by 32. Okay, so if we round that, it'll be 32.5 degrees. 32.5 degrees. Now again, make sure that we are labeling with that degree symbol. So that way we know we're talking about an angle instead of a length of a side. Okay. All right, last problem for this section. So, a 30-story building, which is 372 feet high, cast a shadow 50 feet long. What is the angle of elevation of the sun? All right, so again, I'm going to start with my picture. So here's my building and the ground. So let's see, so this is 372 feet. And this would be my shadow. Let's see, which is, 50 feet. And if this is my shadow, the way I've drawn my picture, that means that my sun is over here. Okay. All right, so thinking of angle of elevation. Well, if I'm thinking about the sun, so it's looking out kind of this way, and then we would have to go down, so that would be here. Now, this would be an angle of depression, not of elevation. So the equivalent then would have to be the one down here. So again, this is important to know that the angle of elevation and depression are congruent. Okay, so when we're creating the shadow, it's actually an angle of depression. So we need to use its equivalent angle down here to find its angle of elevation. Okay. Now, this is my angle. I have opposite. So we're assuming that this is my right angle, so opposite and adjacent, so that's going to be tangent. And again, because we are finding an angle, we are using the inverse. So we will have the inverse tangent of 372 divided by 50. Okay, so that is going to be equal to our angle. Okay. So at this point, I'm ready to type it in. So second tangent to get the inverse, and then 372 divided by 50. And if I round to the nearest tenth, that'll be 82.3. So 82.3, and then our degree symbol. Right, and that is going to conclude section 12-1.